In this clip, it shows the calculations of molar mass molarity and grams calculations we needed of copper ammonium sulfate to get. And for my calculations, we found that we needed 1.25 grams for our 25 milliliter beaker. In this clip, Jesse is adding 10 millimeters of the stock solution, 10 millimeters of NH4OH, and 5 milliliters of water to make the second dilution. She will continue this step 3 more times, and also again for the unknown. From left to right, we have the stock solution, the first dilution, the second dilution, the third dilution, and also the dilution of the unknown. And they are also in cuvette, so we can prepare it for the spectrophotometry. In this clip, Jessie has zeroed out the spectrophotometer, and she is now testing the cuvette samples that we took. She repeats this step for every dilution that we took, including the unknown.
So when you zero the graph, you should get a relatively flat line on your wavelength, because it's not supposed to be absorbing color because it's clear. So when you run your sample, you can see that you get a very different line, because your sample is going to be absorbing light at a certain wavelength depending on what color it is, because that's all light is color. And so you have to scan it at all wavelengths to make sure you know which wavelength it's absorbing at. And then when you go in to compare your samples, you're going to check them at that wavelength. So when you zero,
then okay, go to setup.
You have to make sure that it's in between, say 560 nanometers. And then you press OK.
now you run
Put blank in.
the blank again.
Yeah, you're really supposed to put blank in, then press read, then remove blank, then you put the stock in.
We already read the blank.
Oh, okay.
Okay, so here's sample.
After the spectrophotometer, we then plotted points, correlation versus abundance of absorbance to find the unknown. And we also found the correlation constant and the slope of the line. We then found the unknown solution to be closer to dilution number 2. This is Beer's law, where A is the absorbance, epsilon is the absorbance of the dye, B is the length of the light path, and C is the constant of the dye in the solution.